Good afternoon, tech spinners and aspiring tech spinners. My name is Glenn Wright, and today I'm going to show you a JavaScript tool that I've been building off and on for about a year and a half. I call it VisualSpinner3d, and hopefully I'm not bragging too much. I'm going to bet that it's the most powerful prop spinning simulator that you've ever seen. On this page is one of the interfaces to the simulator engine. So on this page you'll see a viewing window with 2 poi and some controls, several empty menus, and a menu of moves. So the first thing I'm going to do here is drag a 2-petal in-spin flower onto one of the poi, and then a 4-petal anti-spin flower onto the other one. And as you can see, these poi are starting out pointed in 2 different directions, and usually the simulator is going to be smart enough to figure out that how to rotate the move around so that it starts where you want it to. And then I'm going to hit play. And you'll see that it simulates the movements of these 2 flowers. And you see that there's these little sort of ghostly looking poi here. Those are actually showing you where the current move ends, so that you know when you drag another move and add it onto the end of the sequence what it's going to look like, or where it's going to start. So I'm going to put a pendulum on the end of one of these and a 4-petal in-spin flower on the end of the other one. And now, when it finishes spinning the first set of moves, when this blue poi right here gets back to its starting point and the red poi gets back to its starting point, they're going to switch into a different move. And if you want to see that in slow motion, you've got some controls here. You can pause, you can rewind frame by frame, you can skip forward frames, you can go to a specific frame, and then you can start back at the beginning. So you've got a fairly decent set of controls here. So now let's look at some of the things you might want to do with this simulator. So let's say you want to analyze a little bit of a more complex move. So this one is a cat-eye pendulum hybrid that I saw Tim Goddard teach in his workshop at Fire Drums last year, and I've seen Drex spin it in his Combo-rific video. Now, I can't spin it in real life yet, it's a little bit of a mind-blowing one, but the simulator can help me understand how the 2 poi fit together. Now, this hybrid starts in a different position than the flowers. You can't actually get to it directly from this position, and the simulator is not going to be quite smart enough to figure out how to force it into the right position. So we're going to tell it exactly where to start. So we're going to start with the one poi, the hand pointed up at half a tether's length, and the prop pointed up. The other one is going to still have the hand pointed up at half a tether's length, but the prop is going to be pointed down. And then actually this move, that red poi, we're going to have to pivot the whole thing up by 1 tether's length. This is what Drex, when he talks about hybrids, calls a hand-to-head relationship, and that's the starting point for our move. So now we're going to drag a cat eye onto the blue poi, and the simulator is smart enough to figure out from this position you can only go into a vertical cat eye. And then we're going to drag the pendulum onto the other poi. Now this is not your everyday ordinary pendulum. It's sort of an anti-spin pendulum. In my mind I call it an anti-pendulum, and I think Tim Goddard calls it an isopendulum. And so this cat eye is going to spin clockwise, which is the default, so that's fine. The anti-pendulum is going to spin counterclockwise, so we're going to have to actually change it so that it's spinning the other direction. And we can do that by double-clicking on it and just changing it so it says counterclockwise in this little workshop area, and then drag it onto here. And then when we hit play, we can see how this hybrid works. So it starts out with a hand and head together, and then it goes into this kind of unusual pendulum relationship, and then goes back to its starting position. So if you want to understand that in more detail in slow motion, you can click through it frame by frame, and hopefully that can help you understand how the 2 poi fit together. So that's all well and good. So let's say you've put in the time and effort to put this combination of moves together, and you don't want to lose that every time you leave the website. So what you can do is export. You click it, export to JSON, and JSON is a text format that people use to transmit and store data. So from here, after clicking that, you can copy this text to the clipboard, and you could paste it into a text file, but I'm not going to do that here. What I'm going to do is just pretend that I left the website and came back, and then I want to get those moves back again. See, I've lost them, but if I click import to JSON, paste them in there, it's going to know how to build that set of moves just from that text, and then hit play, and it'll work just like it was working before. Okay, so that's one use for Visual Spinner, to help us understand a complicated hybrid. So what are some other confusing moves that a simulator might help us understand a little bit better? Well, I, for one, was confused by toroids, which Drex has tutorials on them in the 200s and 300s. So what I'm going to do now is I'm going to reset these guys to their starting position in the easiest way, which is just to reload the website. Grab an isobend toroid and stick it on one prop, and an antibend toroid and stick it on the other prop. And so you can see here what an isobend and an antibend toroid actually look like. And you might notice there's a little bit of a difference between the way these moves look and the way when Drex spins toroids, how they typically look. And that's because these are sort of the quote-unquote true mathematical forms of the toroids, and when Drex spins them, he makes them a lot more linear, which I think, it's easier to spin, but I think it also just makes a little bit more sense to the person viewing it. So I have those actually added into here as well. So I'm going to add the linearized isobend toroid onto this guy. You know what, actually the way I'm going to do it is like this. I'm going to put the linearized isobend on, going at the same time there, and then the antibend on here, and then, so when I try to add this linearized antibend, it's going to shout at me and tell me I'm doing something wrong, because it doesn't line up exactly with the starting position here, but if I tell it okay, it'll do what I tell it to do. So I'm going to hit play, and you can see that this move is sort of like a linearized version of this move right here. And the hand is sort of teleporting around, which obviously isn't exactly how it works in real life, but you do, when you're making these movements, kind of jerk your hand very quickly. Now it's switched to the anti-bend, and you can see that this is sort of like a very linearized version of the other one. So yeah, now you understand a little bit about isobend and antibend toroids and how the linear ones differ from the mathematical ones. So yeah, mind blown, right? So let's take another move that both Tim and Drex like, what they call the tape deck toroid, which, as Drex mentions in his video, that it's a kind of probend toroid. And I didn't really understand, I mean, probend toroids are very hard to understand, and I didn't really understand why you can think of them as why the tape deck is a type of probend toroid. But now I do, because when you view it in the simulator, whoops, grabbed the wrong one here. I just pressed delete on the keyboard incidentally to make those go away. You can see that this is like sort of the true mathematical one, where this is somewhat more like the way Drex and Tim spin it in their tutorials, even though it's still kind of essentially the same move going on. Okay, so let's take a look at a different interface to the same engine. So here, okay folks, sorry about a slight interruption. I realized that having the screencaster running at the same time that I was running the simulator off the web was causing some choppiness in the video. So now I have switched over to a version of the simulator that I have running on my desktop. It's the same stuff that's on the internet, but it should just run a little bit better with the recording. So what we're looking at now is another version, or another interface to the same engine. And this set of moves that you're seeing here was kind of inspired by John Jonathan Alvarez. If you've ever spun 3 poi and gotten really ambitious and tried to spin 4 poi, and you probably discovered that it's like very difficult. And this move you see here is, well, I don't know if I want to say impossible, but very, very difficult move that I saw Jonathan Alvarez do in one of his videos. It's 4 poi, 2 in each hand, and it's an extension versus triquetra hybrid in each hand. So yeah, not too many people can do this in real life, and I don't think any of them can make it quite this clean. So anyways, you can mess around with these variables quite a bit actually. So let's say we want to see the same move but with mini hoops. This is how we do that. You can make it atomic, make it so that it's going on in the wheel and the floor plane. It'll switch just as soon as it gets back to the starting position. And it looks like the screencaster is still slowing things down a little bit. Occasionally the simulator will slow down a bit, but most of what you're seeing is just because of the encoding from the screencaster. And then you can shuffle moves, and it will like choose a bunch of different moves randomly, so you can kind of get a sense for what kinds of things the simulator can do. So now let's take a look at yet another interface. I'll close. Okay, and this is inspired by the Vulkan Tech Gospel, which it's a framework that Noel Yi, among others, came up with for understanding flower transitions. And this is a demo of 4-petal anti-spin flower transitions going from split same to split, from same to split same to same opposites to split opposites and back again. And I'm not going to go into the details of like how the Vulkan Tech Gospel theory accounts for these things, but you can just get some idea of the kind of transitions you can do using that framework. Okay, now I'm going to do a demonstration of what I think it's the one that I'm most proud of so far. This is, you might recognize this video of Drex spinning some very complex technical moves in the wall plane with a lot of hybrids, mostly maintaining this kind of hand-to-head relationship. And he called this video combo-rific. So what I did, I was actually looking for a really technical video to model in VisualSpinner. And so I basically took Drex's entire routine, which lasts about 50 seconds, and modeled it very slowed down so that you can understand exactly what's going on at every point in time in the VisualSpinner engine. So I'm not going to talk. This takes, I think, about 10 minutes to run all the way through, and I'm not going to sit here and delight you all with my not so witty banter. But if you want to check out the page, you can come take a look at it yourself. So anyways, with the tools that are available on this website, first actually let me go to the actual website, which will probably be a bit choppy, but you guys don't have it on your desktop, so you need to be able to see the actual place that you can go. It's at infiniteperplexity.github.io VisualSpinner3d, and you can here's the actual GitHub page if you're a programmer and want to look at the code, and then if you want to ask me questions, you can contact me at this email address. Just I guess some last notes about what the simulator can do. I tried to make it be capable of doing pretty much everything. The exceptions, it can't do tangles of any kind because these are just sort of modeled as long skinny sticks, and then it can't do body tracing or anything like that because obviously there's no body here. It can do a pretty good job of modeling tosses, contact moves, and a bunch of other things, but I don't have an interface set up that really has a good demo of those put together. This simulator is pretty easy to plug into a website using some pretty basic JavaScript code. So if you have any ideas about other demonstrations or things that you'd like to see modeled, or want to learn about how you can incorporate it into a website or tutorial, just let me know. I talked briefly with Noel Yi about the possibility of having this incorporated in the Vulkan Tech Gospel website, for example. Okay, so everyone have a great day, and I hope you really enjoy playing around with this.